I'm James Johnson, and you're watching Niagara Pro Tips. Welcome back to this multi-part series on BQL. If you haven't watched the first two videos, I'd suggest you go take a look at those before this video. The first two videos cover the basics of the BQL language, how to navigate the help and understand what methods you can use, and gets into the extent and the base ord, as well as the projection. This video, we're going to focus on the predicate of the BQL select statement. But before we do that, I did mention about the help on BQL being in the developer doc, and I do want to just point that out real quickly where that's located. We'll reference it a little bit in this video as well. But in the help system under the table of contents, you have doc developer, and underneath that, there's a topic on queries, which covers BQL, equal, and search. And there's three topics here specifically on BQL. So that's where the bulk of the information related to BQL exists in the help system. And we'll come back and look at this here a little bit later in this section as well. All right, so the BQL predicate, this is used to filter out objects from the result set. And the BQL predicate in the statement is the where clause, which comes after the extent. And the predicate has to be a Boolean expression, which is used to filter objects out of the extent. So the BQL engine uses the base ord to limit the scope, and then it processes the extent of the query against the station, and it finds the working set of objects there. The predicate will then filter things out of that list so that we can limit what actually gets returned. Just like math has order of operations, and you can control the order of operations in math by using parentheses, BQL also has an order, a precedence order by which the operators get processed by the engine. The BQL engine will process the unary operators first, so the exclamation, not, and minus symbol that are all providing some kind of negation. Then multiplication and division, then addition, subtraction, then the various comparators like equals, doesn't equal, greater than, equal to, and so forth, including the keywords like and in. And then lastly, it'll process the and or logical operators. So it is important to understand as you write your predicates, particularly when they get a little bit more complex, that you may need to include parentheses to group your logic expressions to make sure that you get the results that you're looking for. In the bottom, you can see just a very basic example of using a predicate. So in this case, the BQL query extent is looking for numeric points from the station. And then the predicate says where, and the name of one of those control points equals room temp. And in this case, we're doing a string literal, so it's just single quotes around room temp. So that would narrow down to only numeric points that were named room temp in that example. It is possible to build more complex predicates, and in this case, you can see the example with the open and close parentheses around the out.value comparisons. So remember, each time that a row is processed, so we are searching for, in this case again, numeric points, then that's the object for the row. So all the functions in the projection and the predicate are all based on that object, which is being returned for that row. So when it processes each row and it's looking at that numeric point, the first thing it does is says where name equals room temp. And if that's true, then it will also take a look at the out.value. So it's calling get out, which gets the out slot from the numeric point, and then get value, which extracts from the B status numeric the actual value and as a double, and it's comparing it against those two limits being 80 or 60. If we didn't have the parentheses there, then the BQL engine would be going from left to right, and it would test whether the point was named room temp, and if it was, it would check whether the value was greater than 80. And if that wasn't true, then it would say, okay, if regardless of the point name, is the value less than 60? So without the parentheses, that would find a lot more results than we're looking for. The BQL query builder does allow you to build somewhat complex predicates. However, there's limitations with the UI, and the options under the predicate section of match are match all or match any. and the match all functions as an AND gate, and the match any functions as an OR gate. So you can only have all AND statements in your predicate or all OR statements in your predicate with the BQL query builder. So it's a little bit limiting, but we'll talk about that here in a second, and I'll show you what I mean by that. Okay, so going back to the query builder, let's see, we'll go find all points named room temp under the BACnet network. So in this case, my scope's limited under the BACnet network, looking for numeric points where the name equals room temp. And you'll see in this case then, we just see 30 points, which are located under floor 1 and floor 2 for the various air handlers there. And we can see what the syntax looks like here. So my base sort is the BACnet network, and then my projection is just an asterisk, and my extent is from numeric point. So my filter then is this keyword where, and in this case, name equals room temp with single quotes around room temp. And that's an equality operator, so it does have to match exact case, spelling, capitalization, everything has to match exactly with the equality operator there. Using the query builder, I could do something like this, and maybe we'll change this to 77. So you can see the current values 78.2, 76.2 on these two BACnet devices that are actually online and give me values. And so in this case, we're going to say with match all here, that's an AND gate saying the numeric point has to be named room temp and the out dot value has to be greater than 77. In that case, it only returns one item then. And we can see again that there's no parentheses around our predicate. It's just going to be an AND statement here where name equals room temp and out dot value greater than 77. Again, the query builder does not allow me to build more complex statements up or mixture of ands and ors. And in this case, if I were not to use parentheses and just said or out dot value less than, say, 60, this is what I was trying to explain, is how the engine will evaluate this. It's going to process the and then the or. So it's going to use this as a predicate, saying the room temp or the name equals room temp and the out dot value is greater than 77, or the out dot value is less than 60. So in this case, I would get many more results than I was intending to. I'm getting all numeric control points whose value is less than 60, which is not what I was really looking for in that case. So that's where we would want to use parentheses to make sure that we grouped how we wanted the expression to be evaluated by the engine. So if I put a open and close parentheses around the OR comparison, then in this case, it will compare the control point, the numeric point, to see if the name is room temp. And if it is, then it will test to see whether the out dot value is greater than 77 or the out dot value is less than 60. And in this case, because most of the devices are offline and not really communicating, my room temp values are 0. So obviously that's less than 60, and I see all these results being returned. All right. So I want to talk about the keyword like, which is used as a pattern matching comparator. And for BQL, this comes from the pattern class, which is under a private package under COM Tridium BQL expression package. And you won't find a lot of help documentation on private API classes. So definitely wanted to explain this here. I also wanted to emphasize that this is different than what the NQL engine does, the Niagara Entity Query Language. It uses a pattern class, which is under the core Java, under the java.util.regex class, or package rather, and it's the pattern class. And The Java pattern class supports regular expressions, regexes, and it's a lot more flexible with the pattern matching. But BQL uses a pattern class that's in the BQL module, and it has a little bit more limited functionality. So as far as the pattern matching goes with BQL, both an asterisk and a percentage symbol character, they represent 0 or more characters. And then we also have an underscore character, which represents a single character, and it must match exactly one character. Looking at the examples here, trying to give you a little explanation, and then I'll go show you what it looks like in the workbench. So looking for numeric points, and then the predicate says where name like, and then in single quotes, we have asterisk cool STPT. So that's saying the numeric point can be named just cool STPT because the asterisk means 0 or more characters. So that pattern would match on just cool STPT, or it would match on any point, numeric point, where the name ended in cool STPT. Same thing for the or name like percent heat STPT. Percent symbol is 0 or more characters, so that means it would match exactly on heat STPT or any numeric point ending in heat STPT. The second example there, where it says where name like room temp 1 underscore, the underscore is any single character, and it has to be a character, meaning it would not match just on room temp 1, but it would match on room temp 1A or 10, but it also would not match on room temp 102, for example, because that would have an extra character, and the pattern's only looking for one additional character after the number 1 character. Because the underscore and the percentage symbols are used to represent patterns in the comparator, the like comparator, if you actually need to test for an underscore character or a percentage symbol, you'll need to escape that in the pattern, and you do that by using a backslash character. So in the bottom examples there, you'll see the first one, where parent.parent.name like, and then AHU backslash underscore. So the backslash escapes the underscore character, and it's not treated as a wildcard. The pattern is therefore saying the name of the parent device has to be AHU underscore 0, and then the next underscore character represents a wildcard of 1 character. So that would match air handler AHU underscore 01 through 09 would match the pattern. Then the second example there shows where display name like and a backslash percent RH. That's saying I'm actually looking for the percentage symbol, so the display name of the point would literally be percent RH. If I didn't have the backslash, that would match a pattern of any point, numeric point, or any control point rather, ending in RH. So that's where the backslash can be important. So let's take a look at a few examples here. So this is one of the first ones we'll take a look at with the query builder. You can see the scope is limited to the BACnet network, and we're looking for numeric points. In this case, my match function is set to any, meaning that it's an OR statement. And I'm looking for the name of the numeric point to be like star cool STPT, or the name to be like percent heat STPT. So in this case, the asterisk and the percentage symbol are both saying 0 or more characters. If I were to save this query, then we could see how the predicate is configured here in the query builder. And you'll notice that this any function, right, the match any, is using an OR comparator or an OR gate between my two predicate items, where the match all would be an AND function there between the two items in the predicate. So that finds, looking under the BACnet network here, at each of the air handlers, there's an awk cool set point, awk heat set point, unawk cool, and unawk heat set point. So that query is finding these 4 points under all the air handler devices using that like comparator with the match any on the function for the OR gate. back to the query builder here. And in this case, I'm setting the base ord to this light comparator testing folder in the station. And I'm looking for numeric points where the name is like room temp asterisk. So when I run this query, because the room temp and then asterisk means 0 or more characters, it found a match here with just room temp because 0 more characters match the pattern. But it also found room temperature because it matched the beginning pattern of the string. It also found the room temp 1A, room temp 101, room temp 10, and room temp 11. But it didn't find any of these other variations on room temp spellings with different capitalizations or points that might have ended in room temp or things of that nature. So the pattern was looking for exact capitalization of capital R, capital T on room and temp, and any number of characters, 0 or more characters after the letter P. So these all match that pattern. Now, in this case, again, let's actually look under the like comparator testing for numeric points named like, and I want it to start with room temp and then a number 1 character and an underscore being a single character with a mandatory character after the 1. So in this case, it will find the room temp 1A because that matches the pattern with the last A character being 1 more character. It also finds the room temp 10 and room temp 11 because those also match the pattern. But it didn't find room temp 101 because that had an additional character after and didn't match the pattern that we were looking for. In this case, another example, we're looking in the same like comparator testing folder for numeric points, and we're looking at where the display name is like %RH. And in that case, the percentage symbol in this case is interpreted as a wildcard, meaning 0 or more characters before RH because I didn't escape the percentage symbol. So in that case, it found the room humidity, room %RH, and it found AHU %RH, and it found %RH because it was just looking for points where the name ended in capital R, capital H. If I use the escape character then on my pattern, so I use the / character here before the percentage symbol, that will say to the pattern, I'm looking for exactly the percentage symbol and RH. In that case, we should only have one result, which is the 1 point where the display name is %RH actually on the component. All right. Now, jumping ahead a little bit here in that we haven't talked about scalar functions yet. We'll talk about those in the next video. But I do want to show you how this could be important to your predicates as well, because the equality operators or even the pattern matching with like is looking specifically at case-sensitive comparisons. And there's not really a case-insensitive switch that we can turn on like there is with a pattern in the Java pattern class with regular expressions. However, there is a scalar function called lower and upper. And the way these work is that you call the function, and in the first example there, I'm saying lower, and then I'm passing in the name of the control point for each row. And what that function does is it just takes the string that's the name of the control point, and it forces all the characters to lowercase. And then I can do a comparison against a lowercase string. Or the opposite situation is I could do upper in the name and then compare that against a string where all the characters are uppercase. So this will allow you to deal with maybe naming inconsistencies or in capitalization, not in spelling, but in capitalization at least. take a quick look at that. It's not possible necessarily to load a saved query in the BQL query builder like this. We start getting into some complexities with things like scalar and aggregate functions, and typically the query builder doesn't understand how to load that syntax from a saved ord. So in this example, I had built it in the query builder and saved it, and it worked, but it's unable to reload that. You'll see how it kind of splits it across multiple items here. So the idea is that I could say lower name and then say like and room temp, all lowercase. So in this case, what we're saying is look under the like comparator testing folder for numeric points, then run the scalar function lower on the name to convert it all to lowercase, and compare that with the like keyword as a pattern match to all lowercase room temp here. And in that case, what we'll see is it does find room temp with a capital R and a capital T. It finds room temp with a lowercase r, capital T, and room temp with all lowercase letters as well, right? That's the results that get returned. So from a pattern matching standpoint, you can force all the characters in your comparator to lowercase or uppercase maybe to deal with differences in capitalization in your point naming conventions. All right. Now, there's also an in keyword, and the in keyword kind of works in a couple of ways. If we're working with station type queries against the config space, then you're going to utilize a blist expression, which essentially is just an array of values that you want to compare against to see whether the item you're checking is in that array of items or not. So you can see in this case that we're looking for the numeric points that are named room temp. And then we're just using proxy ext.device. I don't remember if we've covered this in the video or not, but when you look at actual driver proxy points like BACnet, LAN, Modbus, and so forth, those extend from a B proxy extension, which is in the driver module. And each control point has a proxy extension. So remember, the extent here is the numeric point, so it's a control point, and it has a method called getProxyExt, which gets the proxy extension slot. And assuming it's a driver proxy point that extends B proxy, then there's a method called getDevice, and that getDevice method will walk up the tree, the ancestors, to the parent device, and it will do that regardless of how many point containers it might be the point might be located in under the point device extension. So it's a more fault tolerant way than doing parent.parent.name, because it might be variable levels depending on how you organize points. So all the proxy ext device called in is doing is walking from the point to the device and then getting the name of it. Then we're testing with the in keyword to say, does the name of the parent device, does it match one of these in the list? So this would only return the room temp from air handler 1, 2, and 3 in this case, instead of all the stations, all the devices in the station rather. The other place that you'll see the in keyword used oftentimes is when comparing timestamps. And so if I'm doing a history query and I get back a bunch of records, all the records from the database, then I might want to limit the results to just a specific time range. And there's a class called BQL time, and it has functions that you can call which return babs time range values. So we're saying, is the timestamp, does it fall within this range of timestamps, where BQL time.today would be midnight, 12 a.m. until the end of today, or the last 24 hours would figure out from that moment in time what were the last 24-hour time range, or yesterday would be 12 a.m. yesterday until 12 a.m. this morning, so the previous day's worth of timestamp values. Right. So let's take a look at a couple examples here with this. We could potentially do something with the query builder on the in statement as well. The in comparator does not show up in the query builder. So this is one that you would definitely need to do just in an ORD field editor and a bound table and a BQL grid and an export source or things of that nature. Temp with in comparator. Right, so let's take a look at what this looks like here. Doing the cook and show thing where we already have things set up. So we're limiting the scope to the BACnet network, and our extent is from control point. And in this case, looking at our predicate, the keyword where, I'm just going to, in this case, I'm using the lower function on the name and comparing that to room temp, which I really didn't need to do in this case, but it was just showing as an example. And then we're walking the functions proxy, get proxy ext, get device, .get name, which gets the name of the parent device. And then I'm checking whether it falls in this array of strings. So air handler AHU underscore 01, AHU underscore 02, or AHU underscore 03. In that case, you can see the results are limited to just those 3 air handlers instead of all 30. All right. And just take a look at the basic query here against the history. So we'll take a look at this BQL ORD. In this case, the base ORD is a history looking at air handler 1 room temp. And you can see the predicate says where timestamp in BQL time dot last week. So we're getting the function that looks up this BABS time range. It's a floating BABS time range. And then we're comparing the records from the history to see if it falls within that time range. So you can see in this case, the previous start of the previous week was 3 August at 12 a.m. And then it's going to have 639 records, which is 672 in a week, but it's going only till 4 p.m. on the 9th. So I must have had the station wasn't running and collecting histories at some point in time last week. So you could certainly change that time here, say BQL time dot yesterday, for example. And now the records are just from the previous day, 96 records from the previous day, 12 a.m. till midnight of the previous day. Right. Now, when working with timestamps, there's some other ways that we can filter records. And you might want to look at hours of the day, for example. So maybe we're interested in the previous week's records, but we only want to see the records that are from 8 a.m. to 6 p.m. You can also do things like the second example of floating time range. So just maybe the previous 3 hours. So we'll go and sort of talk through these here in the workbench as well. BQL time also has functions that return BABS time values, so BABS times, where the previous example was returning a BABS time range when we were using the in comparator. This is getting an actual moment in time. So for example, BQL time.now is the current time of the station, or start of day would be 12 a.m. End of week or start of month would be the timestamp of the start of that particular month or the end of this particular week or things of that nature. All right. Predicate. There we go. All right. So in this case, showing you syntax. You can see again, we're querying the history and we're checking the timestamp to be in BQL time.last week. So the previous week's records. And then we're also filtering down to look for the hour property on the timestamp being greater than or equal to 8, or rather, and the timestamp being less than or equal to 17. So 17 is 5 p.m. using 24-hour time. And so I'm looking for all records between 8 a.m. and 5 p.m. in some number of minutes, so all the way up to 5:59, 59 p.m. When we take a look at the help here, and I know this probably might seem a little bit strange because we're using 12-hour time as our preference, but when we look at the BABS time help document, and the timestamp is a BABS time value, when we look at the method that's public that gives us back an integer called getHour, it returns the hour as 0 through 23, where 0 is midnight and 23 is 11 p.m. So that's why I was using 17 in that example there. Go to this other example here and show you how this one works. So in this case, again, we're querying the same history. And instead of using the timestamp in some time range, in this case, we're checking whether the timestamp is greater than or equal to, meaning it's that time or newer after the time that we're giving it for comparison. And we're using BQL time.now, which gets this moment in time and the current time in the station, essentially. And we're subtracting from that a relative amount of time. So doing a literal here with a B simple, you use the type spec, Baja rel time, and then in single quotes, the number of milliseconds. So that number of milliseconds is 3 hours worth of time. Whenever this query gets resolved, then it will figure out what the current station time is and then do a query for the previous 3 hours worth of records. So you can do a floating time range like this using a little bit of a math calculation in your predicate. There's another way to compare timestamps with histories as well, and this is using period syntax. And I mentioned in one of the earlier videos on the extents about there was reasons why you might want to use the history ID as part of the base ORD instead of using the from keyword and specifying the history ID as an extent. And this is a case where if we want to utilize the period syntax, then we do need to use that format. So in this case, the period syntax supports these periods that are listed in the table: today, yesterday, last 24 hours, week to date, last week, and so forth. You can also specify a start and end time. So if it doesn't fall into the floating time ranges, you can specify exact start and stop periods using the format that you see on the screen. And this is the same as the BABS time encode to string help, right? We're using that ISO format, year, month, day, hour, minute, second, milliseconds, and the time zone offset to set that up. When you look at the query builder and you pick a history here, you'll notice that it provides a time range selector here. And when you pick this time range, like yesterday, for example, what you'll see is that the BQL query builder uses the period syntax and passes in that time range. So you're able to pick from those time ranges that were on the slide there, and that will yield the results that you're looking for there. If you were to go into the query builder and pick a history again, and then pick time range, this allows me to pick a fixed time range and for both start and end potentially. And you'll see that in this case, it uses the period syntax where it specifies time range and then semicolon start equals, and then the ISO formatted date, and then there'll be a semicolon and end, and then the ISO formatted date for the end timestamp as well. So that's how those would look in the actual BQL syntax. Okay. So hopefully that clears things up with the predicates and gives you a better idea of how you can filter things out of your BQL queries to show the results you're interested in. and you learned a little bit more about the keyword comparator with the pattern matching, the in keyword, using either an array of values to test against, or BABS time values for time ranges, and then using the period syntax with the history queries as well to filter results. So stay tuned for more videos in the BQL series. We'll continue talking about scalar and aggregate functions, order by clauses, and lots of other features. So stay tuned.